Hello and welcome to this video in which we are going to be solving 50-ish quadratic equations just to help you get the hang of all the techniques you're going to require for GCSE Maths, the higher level paper. Okay, let's get right into it now. So this first one, we factor out the x and that leaves us with an x minus 4 in the brackets here. And because we've got two things multiplied together that equal 0, one of them has to be 0. So either x is equal to 0 or x is equal to 4, and it's important you write or and not and. Okay, so this is important because they cannot both be 0 at the same time. X can't take these two values simultaneously. Here again we factor out x and then we get x plus 3 equals 0, so we get x equals 0 or x equals negative 3. So you just have to think about what makes this bracket 0. Here we don't have an x term here, there's nothing we can factor out. There's two ways we could do this. We either factor this, but I'm just going to add 9 to both sides. So x squared equal to 9, and then take square root, so we get x equal to plus or minus 3. And then here I'll do the other method. If we factor this, we get x plus 4, x minus 4, so difference of two squares, and that gives us x equals negative 4 or x equals 4. Okay? And that's another way of writing. That's the same as writing x equals plus or minus 4. That's what this means. Here we factor out x again. We get x plus 7, and that implies x equals 0 or x equals negative 7. Here we're going to add on 7 to both sides. We're going to get x squared equal to 7. And that's going to give us that x is equal to plus or minus the square root of 7, which isn't a nice number, so we're just going to leave it as the square root of 7. And that'll be a perfectly reasonable thing to do on an exam. Here, again, we can factor out x, and this implies x is equal to 0 or x is equal to negative 13. And similar problem here. So I'll just run through this quickly. It implies x equals 0 or x is equal to negative 17. This one here, we're looking for factors of 12 that combine to make minus 7. So we're going to factorize this into x minus 3, x minus 4 equals 0. And you can double check this by multiplying out, so we get an x squared term, minus 3x minus 4x is minus 7x, minus 3 times minus 4 is 12. So that implies x is equal to 3 or x is equal to 4. Here we're looking for factors of 4 that add up to 4, so we could have 4 and 1 adds up to 5, or 2 and 2, that works. So let's factorise this to x plus 2 squared, which just implies x is equal to negative 2. Oh, of course that's equal to 0. Here, again, factors of 15, the difference of 2. Well, we want it to be positive, so we're going to take x plus 5 and x minus 3 equals 0, and that implies x is equal to negative 5 or x is equal to 3. Here we're going to have one positive factor, one negative one, and looking at well, 7's prime, so the only factors of 7 are 1 and 7 itself, and this is positive, so we're going to have plus 7 and negative 1, and that implies x is equal to negative 7 or x is equal to 1. Here again, factors of 24, there's quite a few of these, there's still not too many that we can't run through them, and when you do that you find that x plus 8, x plus 3 solves this, and we get x is equal to negative, almost put infinity there, 8, or x is equal to negative 3. And then finally here, factors of 16 add up to 10. Well, 4 and 4 doesn't, 16 1 doesn't, so we're getting x plus 2, x plus 8 equals 0, and that implies x is equal to negative 2 or x is equal to negative 8. Okay, on the next lot of quadratics, we don't have a x squared coefficient of 1, but the beauty with these examples is the x squared coefficient is prime, so it immediately gives away what combination of x terms we have in the bracket. So for example, this first one, let me change my pen color to white and what about this bracket so we can distinguish between answers and questions. This first bracket, it has to split into 2x and an x. We find we need a plus 3 here, which gives us plus 3x, and then a plus 1, which gives us 2x, and then multiplying those together gives 3. Here again 3 is prime, so we have to have 3x and x, and to get 2 we also know we can only multiply 2 and 1, so we figure out the combination that's going to give us 7. So we have plus 1 here, plus 1x, plus 2, which gives us plus 6x. There you go. We're looking to use this to solve equations. I forgot to put this in. So this gives, well, 2x is equal to minus 3, which gives x is equal to minus 3 over 2, or x is equal to minus 1. And here we have 3x is minus 1, so x is equal to minus 1/3, or x is equal to minus 2. This one, 5 is prime, so we're going to get 5x, x, and we can only be multiplying 2 and 1, but 1 is going to be negative. One of them, not one in particular, one of them has to be negative, one of them has to be positive. And looking at this, we can see you get plus 1 to get an x, and then minus 2, which gives us minus 10x, which added together gives minus 9x. And again, might as well put all the equal zeros in here. Implies that this one simply is x is equal to 2, or 5x is equal to minus 1, x is equal to minus 1/5. 7 again prime, so hopefully you're seeing how this simplifies calculations massively. And 10 doesn't have that many factors, and sifting through them all we are going to get minus 5 and minus 2, which gives us minus 14x, minus 5x, which gives us the minus 19x we need. This again is x equals 2, or 7x is equal to 5, so x is equal to 5 over 7. Quickly go through these last two. We're going to get 2x, x, and then we're looking at two numbers that multiply to 9. Well, 3 squared isn't going to work, so we're looking at some combination of 9s and 1s, and we're going to get minus 9 to give us minus 9x, and minus 1 gives us minus 2x, which implies x is equal, 2x is equal to 9, so x is equal to 9 over 2, or x is equal to 1. And before we do this last one, I encourage you to check for any errors in my work, 'cause I'm doing a lot of these, so if I do make a mistake, pardon me, but feel free to correct me in the comments. I won't take any offence. And this one, 2x and x again, and we're looking, so one of these is going to be positive, one's going to be negative, and we're looking to get 5x here. 3 again is prime, so we're looking at a combination of 1 and 3, and we take the minus 1 here to get a minus x, and then a plus 3 here gives us plus 6x, which gives us what we're looking for if you expand it out. And again, that implies, in a similar manner to before, x is equal to 1/2, plug that in, 2 times 1/2 is 1, minus 1, 0, or x is equal to minus 3. Okay, for the next couple of quadratics on this page and the next one, we're going to look at using completing the square to solve for x. So we're going to complete the square of this left hand side, and we're going to halve the x coefficient, add it on, square it, then we subtract 8 squared, which is 64. We still have our plus 3, and that's equal to 0. Well, this implies x plus 8 squared minus 61 is equal to 0, and that implies x plus 8 squared is equal to 61. So x plus 8 is equal to plus or minus the square root of 61. so I don't know why I've put a 1 there, which implies x is equal to minus 8 plus or minus the square root of 61. Nice one. And we're going to go through the same technique for the next two. Yeah, so again, we half this coefficient, plus 5, get the square, take off 25, we still have our 19 on the end, that's still equal to 0. Combining these two terms, we get x plus 5 squared minus 6 is equal to 0, which gives us x plus 5 squared is equal to 6, which gives us x plus 5 is equal to plus or minus the square root of 6, which implies x is equal to minus 5 plus or minus the square root of 6. All these could be done using the quadratic formula and the ones on the next page, and we will have a look at some where we will use the quadratic formula, but it's just nice to show you all the different techniques. So now this last one, exactly the same technique. Minus 1 here, 1 squared, minus 3, and that is equal to 0 still, implies x plus 1 squared minus 4 is equal to 0, and that implies x plus 1 squared is equal to 4, implies x plus 1 is equal to plus or minus 2, so this one square roots quite nicely, and then subtracting 1 from both sides, we get x is equal to minus 1 plus or minus 2, so that's x is equal to 1 or x is equal to negative 3. So this one clearly could have been done using factorisation instead of this technique. Okay, so now we'll go on to some slightly more difficult examples of completing the square. A couple of quick examples with negative x coefficients, and just to show that this doesn't change the technique. So we still just half the coefficient, minus 2 squared, and then minus 2 squared is the same as 2 squared, so we're still subtracting 4. We've got our plus 1, that's equal to 0. That implies x minus 2 squared minus 3 is equal to 0, which implies that x minus 2 squared is equal to 3. Again, that gives us x minus 2 is equal to plus or minus the square root of 3, which implies x is equal to 2 plus or minus the square root of 3. One more example of these. We half this minus 6, we get minus 3 squared. Minus 3 squared is minus 9 plus 3 equals 0, and that implies x minus 3 squared minus 6 is equal to 0, implies x minus 3 squared is equal to 6, implies x minus 3 equal to plus or minus the square root of 6. Does not look like a 6, but it is. Now it looks like a sigma. I'm going to have to rub that out and neaten that up. Plus or minus the square root of 6 implies x is equal to 3 plus or minus the square root of 6. There we go. Just a quick reminder that throughout this video I'm doing a lot of these calculations, so be sure to point out any mistakes I make in the comments. That would be much appreciated, and then I'll leave a note in the description to point these out to future viewers. But yeah, on with some more quadratics. These next two quadratics, we're going to look at completing the square, but when the x squared coefficient is not 1, or is greater than 1. So what we do is we factor out whatever the x squared coefficient is, but just out of the first two terms we leave this term by itself. So we're going to get, let me change to the white pen, we're going to get 2 x squared plus 3x plus 1 equals 0, and then we're going to complete the square of this bit in the middle, so we're going to get 2, and then in here we're going to get x plus 3 over 2, halving that x coefficient squared, and then we subtract this squared, so that's 9 over 4. Okay, and we still have our plus 1, and that is equal to 0. And then we just multiply this out, so we get 2x plus 3 over 2 squared minus, well, 2 times 9 over 4 is 9 over 2 plus 1 is equal to 0. 2x plus 3 over 2 squared, and then combining these, well, 1 is 2 over 2, so this is minus 7 over 2. Okay, and that's equal to 0. That implies that 2x plus 3 over 2 squared is equal to 7 over 2. Implies x plus 3 over 2 squared is equal to 7 over 4, which gives us that x plus 3 over 2 is equal to plus or minus the square root of 7 over 2. Okay, and then subtracting this implies that x is equal to minus 3 over 2 plus or minus the square root of 7 over 2. Doing this one, we do a very similar technique, well, an identical technique. So let's just run through this one a little bit quicker. And then we're completing the square in here, so we get x plus 3 over 2 squared minus 9 over 4 plus 2 is equal to 0. Multiplying out implies 3x plus 3 over 2 squared minus, well, multiplying by 3 doesn't simplify it as nicely, but multiplying the 9, we can multiply the 9 by 3, we get minus 27 over 4 plus 2 is equal to 0. Well, 2 is 8 over 4, so writing this out we can get 3x plus 3 over 2 squared, and we're going to add this on, so we've got 27 over 4 and minus 8 over 4, and that is 19 over 4. We're then going to divide by the 3 and take square root, so that gives us x plus 3 over 2 is equal to plus or minus the square root of 19 over 12. Implies x is equal to negative 3 over 2 plus or minus the square root of 19 over 12. These next three quadratics we're going to solve using the quadratic formula, and hopefully you remember what that is, but for a quadratic of the form of these, it is that x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, where a is the x squared coefficient, b is the x coefficient, and c is the constant coefficient. So this is a nice way to immediately give us the answers. So here x is equal to minus 7 plus or minus, well, the square root of b, 7, is 49, and then minus 4ac, well, a is 1 and c is negative 1, so this actually becomes a plus 4, and then all this is over 2, and that is equal to minus 7 over 2 plus or minus the square root of 53 over 2. You can take the half out if you want, but I'm just going to leave it as it is. Here we have x is equal to negative 5 plus or minus square root of, well, 5 squared is 25 minus 4ac minus 4 times 1 times 2, so that's minus 8 over 2 times 1, which is 2. So again, similar result, is equal to minus 5 over 2 plus or minus the square root of 17 over 2. And then here we get minus b is 4 plus or minus the square root 16 minus 4 times 1, so that's minus 4 over 2, so that's equal to 2, 4 over 2 plus or minus the square root of 12 over 2. Quadratic formula problems, but this time a is not 1. So we'll just get straight in, and that is x is equal to minus b, so 5 plus or minus the square root b squared, 25, minus 4ac, so 4 times 2 times 1 is negative 8, but this time we're dividing by 2a, and 2a is 2 times 2 is 4, so x is equal to 5 over 4 plus or minus the square root of 17 over 4. Brilliant. And then next up we have this one, 3x squared plus 2x minus 5 is equal to 0, and that is minus 2 plus or minus the square root of 2 squared, so that's 4, minus 4 times 3 times negative 5, so that's actually going to be a plus because the negative multiplied by the negative 5, so 4 times 5 is 20 multiplied by 3 is 60, and all this is over 2a, which is 6, so this is equal to minus 1/3 plus or minus the square root of 64 over 6, so the square root of 64 is 8 over 6, and you would want to in an exam. And here we've got minus 3 plus or minus, we should clarify that this is x, plus or minus the square root 9 squared. Okay, so we have a negative power here, so we've got 4 times 4 times negative 2, and we're subtracting that, so that is plus 32 over negative 4, so that's equal to 3 over 4, because negative 3 over negative 4 is 3 over 4. And then we could flip this over and say minus and then plus, but it doesn't matter. We've still got plus or minus the square root of 41 over 4. We can omit the negative 4, because like I say, if we take the negative out, well, we're adding and subtracting anyway, so those two solutions just like essentially swap over, but we've still got the same solutions there. So y is equal to x squared plus 3x plus 2. We're asked to find the roots and also to plot it. The roots are where y is equal to 0, so we've done a lot of examples of solving equations like that, so let's do part I first. We're going to set y equal to 0, so y equal to 0 implies x squared plus 3x plus 2 is equal to 0. Factorising, we get x plus 2 multiplied by x plus 1 is equal to 0. So that implies x is equal to negative 2 or x is equal to negative 1. And those are the roots. So now for part 2, we're plotting it. So we already have the 0, so at negative 1 and negative 2, and we know that quadratics either take an n shape or a u shape, and this all depends on the x squared coefficient. So the x squared coefficient here is positive, so we take this u shape and we draw a nice smooth curve between the two roots with the turning point between the two roots. In solutions, we want x squared is equal to negative 4. Clearly has 0 solutions because you can't take the square root of a negative number and get real solutions back out. For the next ones, we're going to use something called the discriminant. We're going to use b squared minus 4ac, and we're going to consider the value of this. So if you remember from the quadratic formula, this is the bit under the square root. So if this is greater than 0, we have 2 solutions. If this is equal to 0, we have 1 solution, 1 repeated solution. And if this is less than 0, we have no real solutions. So what we're going to do is calculate this every time. So b squared minus 4ac here is 3 squared minus 4 times 1 times negative 7. Well, we're adding on a positive to a positive, so it's clearly greater than 0. We don't even have to calculate it. So we have 2 solutions. You should say 2 real solutions. Yeah. So here we're doing 5 squared, and then we're subtracting 4 times 2 times 6. So that's equal to 25. Well, 4 times 6 is 24, so minus 48. That's clearly less than 0. So this has no real solutions. Okay, and here again we're going to do the same technique. So we're going to get, well, minus 4 squared is the same as 4 squared minus 4 times 3 times 1. So that's equal to 16 minus 4 times 3, which is 12, is equal to 4 greater than 0. So that is 2 real solutions. And you can write 2 real distinct solutions if you want, but you don't have to. And then here, again, we're getting b squared minus 4ac, so 3 squared minus 4 times 1 multiplied by negative 5 greater than 0. Again, because we're adding on a positive number to another positive number, so we don't even have to calculate it. 2 real, right at this time, distinct solutions. Final example, we've got 1 squared minus 4 times 5 times 1, and that is clearly less than 0, so we have no real solutions. The last 3, and the idea of these ones is you can just pick a technique you want to try solve them. I'm not going to specify which one, and we'll just see if we can get them. So for this first one, I'm going to choose factorisation because I've noticed that this is prime, which gives us a nice hint at how to factorise it. So we know we have a 3x and an x. Well, 15, we can either have 1, 15, 3 as a pair, or 3 and 5 as a pair. It's pretty clear from our target that we need 3 and 5, so if we have plus 5 here, we get 15x, and then plus 3, that gives us the 18x, which gives us either this is 0 or this is 0. So x is equal to negative 1, so negative 3 over 3, or x is equal to negative 5. The other way we could have done this, and definitely the easiest way, is notice that this cancels with this to give 6 here and 5 here, and then you can just factor that quadratic out. Okay, so you can divide through by 3, because if this is all equal to 0, then taking out 3, that's equal to 0, and 3 is not 0, so this has to be 0. Okay, so that's the other way of doing that. This one we're going to do using the quadratic formula, so x is equal to minus b, so minus 5, plus or minus the square root of b squared, so 25, minus 4ac, but that's plus 4 times 3, because we've got a negative 3 there, that's all over 8, so that's equal to minus 5 over 8, plus or minus the square root of, and we have 25 plus 16 times 3, and this is going to test my mental arithmetic a bit. So 16 times 3 is 48, plus 25 should be 73, and that's over 8 as well. Okay, and we'll just leave our answer like that. And this last one I'm going to do by completing the square. So what I'm actually going to do is I'm going to add on the 18 first, and then just complete the square of this side. So we're going to get x plus 3 squared, and then we have to subtract 9 because that's not actually featuring on this side of the equation, which gives us that x plus 3 squared is equal to 27, which gives x plus 3 is equal to plus or minus the square root of 27, which implies x is equal to negative 3 plus or minus the square root of 27. And that wraps up this video. Hopefully this has given you sufficient practice on quadratics. If you still have any questions on quadratic equations, be sure to let me know down in the comment section below, and I'll try my best to clear up any issues you may have. But for now, that is it. Thank you very much for watching, and I hope to see you in the next video.